In this video analysis, we're going to look at the mechanics of the pull phase. The pull phase is defined by an arm in water in motion creating propulsion, which means that the start of the pull is once the arm starts moving in the water. This can be after the arm has entered or after the glide phase of freestyle. The end of the pull phase is defined by the arm breaching the surface of the water. If we look at the pull phase, many people perceive the pull phase or the end of the pull phase as the arm brushing past the leg. But as we can see, if the arm is still in the water and in motion, then the pulling phase is still active. To optimally control the pull, the goal is to ensure that we move the largest body of water from the start to the end of the pull with the least amount of effort. This means that at the start of the pull phase, the arm has to maintain as much surface area as possible to move as much water volume as possible. Depending on the load on the arm, this may mean creating a shape of leverage so that the arm can encounter more load. This is known as the catch phase of freestyle, where the elbow bends at the very start of the pull phase. It's important to note that when implementing a catch, the way a good catch feels and the way a good catch looks are two very different things. You'll notice here that the bicep-tricep area of the arm, which is just here, moves as the elbow bends to create the catch phase. However, when you implement a good catch, it will often feel like this area of the arm stays completely still. But in reality, we can see that the elbow bends and the bicep moves. To say that again, make it feel like the bicep-tricep area of your arm stays still as you bend your elbow and forearm at the start of the pull phase. If you are a beginner swimmer or swim very slowly, the catch phase is less important. To work on a catch, maintain a good glide phase to ensure that you can orientate your arm in the right manner. Regardless of the pulling phase and the start of the pull, to maximize the back end of the propulsion phase, the arm must extend towards the water surface. Many people look to push the arm towards the surface or increase their propulsion by feeling activation across the arm. As the arm passes halfway through the pull phase, we lose vision of it, and it's very easy for the stroke to start to collapse. To give you an example, we'll have a look at a different swimmer. You will notice that this swimmer, from halfway through the pull phase, they lose surface area on the arm. The arm tucks close towards the body, losing surface area and the amount of water moved, which means they lose propulsion. Now this swimmer felt like they were maintaining consistent stroke rate and their arm was moving as long as possible. But in reality, the pull phase started to collapse. Their focus was to ensure that from halfway through the pull phase, they extended towards the surface. We can often perceive the pull phase as trying to make it as long as possible, but the signals that the brain is giving the arm is to extend. So regardless of the pull shape of the arm, it's important to extend the arm towards the surface of the water from halfway through the pull phase. The goal will be to breach the surface of the water extended, which tells you that you've moved a large body of water. Many swimmers dwell on ensuring that their arm breaches the water extended without first trying to ensure that they can extend their arm through the water. It's important that when you read your arm hitting the surface of the water, it's a reference to the control that you applied during the pull phase. The last thing to take note of when controlling the mechanics of your pull phase is that if your arm extends towards the surface, because the arm is moving a greater distance, the duration increases, which means that your stroke rate will decrease, however propulsion will maintain, or if anything, your propulsion will increase. To say that again, to control the back half of the pull is to ensure that you extend your arm from halfway through the pull towards the surface of the water. Extend your arm so that the arm breach is extended. If the arm breech is bent, apply more work and more duration on the following pull phase. To come back to our underwater to look at the start of the pull, we recommend maintaining a glide, and then if you're looking to create leverage, get the feeling like your bicep-tricep area of your arm stays where it is and you bend from the elbow as you start your pull. As you implement the catch, you'll then continue to move this area of your arm, the bicep-tricep area of your arm, with lots of surface area on the arm towards that halfway point. From there, just focus on extending to the surface of the water. That sums up the mechanics of the pull phase. You will notice that the content is quite simple. At the end of the day, when we control our mechanics, we are controlling the way that we move water volume. It's easy to dwell on subjective language like length, push, propulsion, or rhythm. Think about your mechanics, and you will ensure that the control that you are applying actually happens in the water. If you found this video useful, be sure to like the video below, and you can support us by subscribing to our channel.